Okay, at this point, you should have been able to get this one. So all you have to do is say, we know we have to have underneath our, there's two ways we can do this. We can either literally graph this and look at our domain, or we can just say, we know we can't have a negative underneath the radical. So you'd say, this is a true statement. 4x minus 4 has got to be greater than or equal to 0. It can equal 0. Solve for x. So you'd add 4. If you do it this way, you just have to remember if you divide by a negative, you change your inequality. Don't forget that. So we'd add 4. So we have 4x must be greater than or equal to 4. Divide by 4. So x must be greater than or equal to 1. All good? The other way is to graph it. Wouldn't we factor out a 4? Left would be x minus 1, correct? You guys see what I did there? So that's 2 square roots of x minus 1. So it shifted right 1, technically. So then it would be a square root like this, so 1 to infinity. So x value is greater than or equal to 1. Okay, let's do problem number 2. Given negative 2 times x minus 3 squared, a quadratic plus 7. No, inequality is like what we just did. Because there's interval notation, which is like negative infinity up to whatever, or infinity, you know what I mean? 7 to infinity, or whatever it is. Inequality is writing. But isn't range y values? So you need to be saying y. Yep. By yourself. You will be that special sophomore if you're not taking this time seriously. So I just drew a picture, a rough picture, right 3, up 7, and then it was reflected over the x-axis, stretch of 2. So right 3, up 7 looks something like this. That's all I needed to look at. So then are my y values below? So if you wrote it as an interval notation, you would say negative infinity up to 7. Right? Negative infinity up to 7, including 7. But it asks it as an inequality. So our y values are less than or equal to 7. A lot of you got it right. You guys got it? Okay. Right? But you shouldn't need to use a calculator to graph this one, just saying, but you could. Okay, next one, go. Yeah, so I think we're missing something on this one from last year. I think they probably would have given you another criteria, like it says, with 2 imaginary solutions, or like with imaginary solutions, or maybe with whole number solutions, or real solutions, so or integer solutions, whatever. Anyway, so it all just depends if that, but you're right. Based on this, we could just write any old quadratic. So, good point. Like 10. Okay, so let's maybe, I don't know, that was just so easy, but oh well, you guys get it, right? If it had imaginary solutions, they'd have to be the same imaginary solutions, right? But conjugates? Yep. Okay. Okay, perfect. So then you could use x equals 1, x equals 2, for example. Anything. Does that make sense? Work backwards, nice. Okay, next one, number 4. A cross-section of a cone is a polygon. How many sides? Wow, I struggled typing this. How many sides would the polygon have? You did. It doesn't matter. It's saying what shape. We could slice it there, there, there. Isn't the shape going to be the same? Not really. Yeah, it is. There would be different sizes. If we look at a cone from underneath, guys, doesn't it look like this? Right. There's my cone that's up. I don't know how to make it look 3D. Okay, so we're looking underneath the cone now. If we sliced it on that kind of, like if I took a piece of paper and sliced through this, the paper, let's take our paper and slice through it this way, for example, isn't it going to make a circle? Does that make sense, everybody? If I sliced it there, there, anywhere, isn't it going to be a circle? This is going to be a smaller circle, right? Up here, but a little bit larger of a circle, just depending on where it was sliced. So it'd be zero side. I mean, one side, I guess. Would a circle have just one side? I don't know. Yeah. What? Or would it be considered zero sides? It is? I don't know. I'll look it up and say how many. Let's look it up on the internet. It's like one top. It would be different. What if we took and sliced the paper right like this? What kind of shape would that make? Would that make a triangle? I think that would. 3. If we slice it like that, that would, think about cutting a cone like that. Did you see how that would make 3 sides? Well, you'd be looking at when it says the cross section, that means where they cross, what does the shape make? So that's why this one's a circle, because where they cross makes a circle. Yes, exactly.
So if it were a triangle,
right. I think, in my head, that's what I see. Don't you see that? Same thing? We cut it with this red paper, that would be making it into a triangle, wouldn't it? So it just depends how we're slicing it. But if it doesn't specify, assume it's sliced like this. Everybody understand? You guys keep asking that, but it wouldn't it be a circle no matter where? Think about slicing a cone at the top. It's going to make a small circle. So if I cut it down here like this, it's still a circle. Number 5, go for it. I'm going to look it up while you're doing this one. Please do this one. So it says right here that it's a point on a circle is an extreme point, so it makes sense to say it has uncountably many corners. Though the notion of whatever. So it says that there are 0 sides of a circle. It says if the definition line segment joining 2 vertices, then the answer would be 0 for the circle. Me too, but it's 0. Stop doing that. Stop. Don't touch it. Okay, what did we get? We multiply by pi over 180, right? Did we all remember that? Yep. Yep, the pi's have to cross out. I'm really distracted because I feel like people are not taking this time seriously. What time? I mean, what did you get? Okay, next one. Okay, ready, go. So this one says, given this, 1/2 times 5x plus 2, we have this. It's hard deciphering what it's saying, so I'm not going to decipher it for you. But, so we have negative 2 over 5 comma 5. So now given h of x is negative 5, absolute value of x minus 1 plus 3, and we know that that's AB, what's AB? So you're kind of figuring out what are they trying to go for here. This is what it should have been. I don't know why I didn't write that plus 5. Guys, can't you see that this is obviously the vertex? If you don't know what the vertex, yes you do. Vertex is, okay, well then did Miss Burton, we need to go talk to Miss Burton. Okay. Vertex is the lowest or highest point of a quadratic or any function really, right? Okay, so don't we know that shift for all functions work the same? I didn't mean to draw that. So wouldn't this be a shift of left 2/5? Because you would set that equal to 0 and solve, right? We have to factor, basically. Okay, so then from there, we shifted up 5. So if that's true, then what do we know about AB here? 1 comma 3. That would be correct. Okay, so next one is this an example of an inverse? So you would put, what they'll say on the stage is click on all of the ones ones that are inverses, are examples of inverses. Well, let's talk about it because maybe these examples maybe are easier than the ones you might see. Remember, we can determine if things are inverses if they're a reflection over y equals x, right, everybody? Remember that? A reflection over y equals x will make it an inverse. So that would be a y-intercept of 0, 0, a slope of 1. That's why I drew it like that. Everybody see? So if I snap that across that line, it would create that. But we would make absolute sure, because also we know an inverse of xy would be y comma x, correct? You switch your x, y. So like this point, -2 of zeros, inverse would be over 0, -2. You just switch your x, y points. So I'm going to check all of them. They're good. So over here, it kind of appears like almost, but they're not. Because look, this is -2 up 1. So we should be going over 1 down 2. This is over -3 up, oh wait, -2 up 5. So we should be going over 5 down 2. Does everybody understand? So we'd say yes to this one, no to this one. And then with this one, did we just switch x and y? Yeah. Yep, so this one's a yes. And D, no, because there's a negative in there. And then this one, with an equation, we would set this so y is equal to x plus 2. Let's find the inverse. You switch x and y. X is equal to y plus 2. You subtract 2. So y is equal to x minus 2 is the true inverse. So this would be a no. And this one, we would subtract 4, correct? Square root it in the correct order. So you could go through and do the algebra. So we should first subtract 4, then square root it, and then plus and minus, so yes here. Questions on that? Okay. Plot the zeros. Ready, set, go. So basically find the zeros, and then you know how to plot the zeros. So we would find the zeros, we would factor it completely. So this part's already factored. We'd factor this, well, multiplies to be 6, adds up to be 5, 0, 3, and 2, right? We can quick factor it because this is 1. So this factors to be x plus 3, x plus 2. So then you'll set each of those equal to 0 and solve. So we get x is equal to 1, x is equal to -3, x is equal to -2. So if we graph that, it would be here, here, and 1. And then I just want to ask you a question. If they said draw in the picture correctly here, we would then have to draw in a couple more things. So that's plotting the zeros. But now think about it. What's my end behavior? You shoot it. Down and up. Isn't it? Wouldn't we look at the leading term only? X times x squared is x cubed. Isn't it positive? So you're right. It's like a positive line. Does everybody understand? So then you could go to this and go down and up for sure. Correct? Now drawing in the in-betweens. Remember back to the test, we can't just draw a rough sketch, right? We would find a point in between them, right? So that we're a little bit more accurate. We'd find the point between them and plug it in. So obviously it's going to come up and cross because it didn't bounce, because that would be multiplicity, right? If there was x equals -3, x equals -3, that's when it bounces, right? So we know it's coming up, but we don't know how high up to go. So we would plug in -2.5 into the function and calculate it to see exactly how high up or down to go. You could, or you could just plug it straight in and put it in your calculator. So type in, like let's plug in, so we're doing x equals -2.5. Let's see what it is for me real quick. You just type it in. You don't have to multiply it out. So -2.5 comma what is on my graph? And you can just hit enter. 44? Did you all get that? 44.1. Okay, so it's going like clear up here, right? And then it's coming back down. Isn't it gonna definitely cross through there? And then it's gonna, and then we could plug in, let's maybe plug in like -1, 0, and then we could finish this off. Everybody good? I don't want to take the time to do that. Okay. Okay, solve for x, go. You're forgetting an answer. No. Yep. Not plus or minus that answer. No. Okay. Now remember, to undo this, we'd raise both sides to the 3/2 power. Okay, now remember what that really means. So this and this cancel out. So we have 2x plus 3. Now over here I have 64 to the 3/2 power. What does that really mean?
Yeah.
The square root of 64 to the 3rd power, because roots go on bottom, power goes on top. So then we really have 2x plus 3 equals plus and minus, what is the square root of 512? Is this 512? No, that would be the larger. That is 512. But we can't forget plus or minus because it was a square root. 90% of you missed that on the test, and we're doing it again, so it's a good reminder. So then you'd split it up, you'd say 2x plus 3 equals 512. 2x plus 3 equals negative 512. In fact, in regular secondary 3, I don't even teach them to raise it to the 3/2 power because 100% of the time they will forget. The only reason I showed, so every time I literally make them rewrite it as a radical so that they don't forget to put plus and minus. Because they know to do it, does that make sense? But if they do the 3/2, they forget. I mean, you guys are honors and all of you forgot too. You get what I'm saying? So you've got to remember that. I know it's hard to remember, but does that make sense? Okay. So then you'd subtract 3, 2x divided by, and then divided by 2, subtract 3 divided by 2. Everybody good? Yeah, they are different answers. And then we need to check both. So x is equal to 250. And then right here you have 2x equals negative 515 divided by 2. And you got x is equal to, what was this one again? That. Then you would check both of them by plugging both in, because there are extraneous solutions at times, if you'll remember. So I just can't stress it enough. Once again, if you need to rewrite it as a radical, do, so that you don't forget plus and minus. Okay. That's it.